Welcome everyone, and welcome to the AluVET Vocational Training and Education for the Aluminium sector. This training is co-funded by the Erasmus programme of the European Union. I am Jan Lukaszewski, the Technical Manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explains the simple theory of metals and of metallurgy to enable students in subsequent modules to understand aluminium, its alloys, heat treatment, and how it is rolled, extruded, and/or welded. This project is funded with the support of the European Union. This publication reflects only the views of myself and the Aluminium Federation, and the Commission cannot be held responsible for the use which may be made of the information contained therein. This module will provide the basic theory of diffusion required for future modules to understand the metallurgy of heat treating, that is age hardening aluminium, and of solid state welding. The basic understanding of diffusion of solid solutions and their behavior is essential to understand how to heat treat aluminium alloys. The basic understanding of diffusion of solid solutions and their behavior is also essential to solid state welding. And finally, the basic understanding or knowledge of diffusion of solid solutions is essential to understand how heat-treated alloys react to thermal welding, that is fusion or temperature welding. So let's understand what diffusion is, and particularly self-diffusion. Now, please remember that individual metal atoms are not bonded to each other, but are held in place by the metallic bond by the clouds of electrons. This means that even at ambient room temperature, individual metal atoms can migrate around. They diffuse, that is, travel, move about through the solid state structures with time. So individual atoms can actually move around within the crystal atoms. This means that individual atoms travel or migrate, that is, move through the solid state. The individual atoms diffuse, migrate through the solid state in order to equalize out any concentration variations to create an equilibrium. So they try to equalize out any alloying non-equilibrium conditions. The equilibrium is when the concentration and distribution of both solvent atoms and solute or alloying atoms is even and the same throughout the whole solid state. Diffusion involves the migration, travel of atoms, so is time dependent. The longer the time, the more diffusion can occur. The mobility of atoms involves time, but it also involves temperature. And even at ambient temperature, metal atoms migrate around. That is, they diffuse throughout the structures. This is because individual metal atoms are not bonded to each other, but are held in place by the metallic bond of the clouds of electrons. This means atoms are free to move in all directions to create an equilibrium. It's so important to understand that individual metal atoms are not bonded to each other, but held by the clouds of electrons and the metallic bond. If we increase the temperature, we expand the lattices. Remember expansion? The electrons move out, separating atoms more. Expanding the lattices reduces the strength of the metallic bond, enabling easier diffusion. Therefore, increasing the temperature increases the mobility of atoms, increasing freedom of movement. So increasing temperature increases mobility, increases the rate of diffusion. Thus, diffusion is a function of temperature and time. Diffusion is a phenomenon of material transport by atomic motion. It is time and temperature dependent. So atoms move from an area of higher concentration, red atoms in this case, to an area of lower concentration within the green to create an equilibrium of both solvent aluminium and solute alloying atoms. So diffusion equalizes the equilibrium. Atoms move from an area of higher concentration, the red atoms, to an area of lower concentration, green atoms, to create an equilibrium of both the solvent aluminium and solute aluminiums. They redistribute themselves, they migrate within the microstructure until an equilibrium is achieved. Now, atoms can be redistributed between different alloys. In an example from fusion welding filler metals into the parent metal, atoms can be added from the external materials and environment through contact, through immersion. Hydrogen can be picked up from water. Atoms from the alloy can be discharged to the atmosphere, for example, hydrogen gas being evolved.